Hi, welcome to my video on rational functions, and in this video we're going to look at the function f of x equals. Notice this is two linears multiplying to give you a quadratic of x squared, and this is a linear on the bottom. So in the next two videos we're going to look at a quadratic divided by a linear, and a, b, c, d, e, and f are real numbers. And this is number one, when we have a quadratic, which is x squared, being divided by a linear, which is x. But before we get into it, let's review a little bit. A rational function in this video, or rational functions, have the numerator with a degree of 2, quadratic, and the denominator with a degree of 1, linear. And an example of that, let's look at the f of x is equal to x squared plus 3x minus 2 divided by x minus 1. So notice the numerator, the degree is it's 2, and the denominator is the degree of 1. Quadratic divided by linear. And let's also look at another one, again similar. It's x squared, which is a quadratic, divided by x plus 3, which is a linear. These are different. These are special. Again, there are many of these to do. We could have a cubic divided by a linear. We could have a quartic divided by a quadratic, etc., etc. But I'm just looking at when the degree of the numerator is larger than the degree of the denominator. And one of the easier ones to look at will be this one. So each of these will have a vertical asymptote. And the vertical asymptote is when x minus 1 equals 0. That means x is 1. Or it could have x plus 3 is equal to 0 on this one. So x is negative 3. So the denominator cannot be 0 because it'll be undefined. So it has a vertical asymptote at 1 and negative 3. But what happens in this one, because the numerator is a quadratic and the denominator is a linear, then the asymptote will be oblique. So the horizontal asymptote will be an oblique line. And let me explain that. An oblique, let's say we have the x and y axes like this. The asymptote will be like that. Or this is the x and this is the y. The asymptote will be like this. It's an oblique. So, and that's found, and we find that by dividing the denominator into the numerator. So let's take x minus 1 and divide it into x squared plus 3x minus 2. So we're going to divide the denominator into the numerator. And so x divided into x squared is x. We put the x above the 3x. X times x squared, x times x is x squared. X times negative 1 is negative x. Draw a line. Now we're going to add on the opposite. We're subtracting. So that makes that a minus, and it makes that a plus. So I circled to show I made the change. That cancels out. And so it could be 3 plus 1 is 4x, and bring down your negative 2. Now we divide x into 4x to get a plus 4. Multiply back, we get 4x minus 4. Draw a line, and that's a plus, so we change the sign to a minus, and we change the negative to a positive because we're adding on the opposites. So as a positive, negative cancels out. So that's a minus 2 plus 4 is 2. So what happens when we divide here? So that means that this division is made up of, so we could say this is the f of x. So this is expressed as this. So it's x plus 4, and it's 2 is the remainder, and it's an x minus 1 as a divisor. So this fraction right here is expressed as x plus 4 all over 2 x plus 4 and 2 over x minus 1. So we we multiply this out by FOIL and add 2, we will get this numerator divided by the denominator. And this will be, as you see, this is going to be your horizontal asymptote. So I'll just show you that. Just draw a little grid. So this is x and y. So this is y equals x plus 4. Now, x is 4. Let's say x is 4 right here. And the slope is 1, so it's 1 over 1. So you go up 1, right 1, up 1, right 1. So this is the horizontal asymptote right there. So the graph will not pass through this oblique. It's not horizontal. It will not pass through. When I said the horizontal asymptote, it's not a horizontal asymptote. It will have an oblique asymptote, OA. It's an oblique asymptote. It will be an oblique line, a line that goes up to the right or down to the left. So there's the oblique asymptote. So that line is y equals x plus 4, but it's an asymptote, so it's broken. And while we're at it, another way to this division is to do it by synthetic division. This is x minus 1, so we take a 1 and we divide into, so that's 1 plus 3 minus 2. 3 minus 2. We draw a line down here, bring the 1 down there. So 1 times 1 is 1, add 4. 1 times 4 is 4, add 2. So when you take this x minus 1 and divide by synthetic division, this 1 goes into here. So that gives us x plus 4, and the remainder is 2. So there it is there, written in this fractional form like this. And let's look at this one as a division. What about if we take x plus 3 and divide it into x squared minus 4? So x squared, but as we write this down, we have to fill in, so that's a square, so we have to fill in a 0x and a minus 4, because in descending order is 2, 1. There's a constant there, x to the 0. So when we fill in the 0 here, to do the division by the long way, so x into x squared goes x. Multiply back, we get x squared plus 3x. We're subtracting, so we change that to a negative. That's a plus, so we change it to a negative. So I change the sign, I put the circle on, notice that. So positive x squared, negative x squared is 0. This is 0, add on negative 3, so that's a negative 3x minus 4. X into negative 3x is negative 3. Multiply back, negative 3x minus 9. And we're subtracting, so we make that a plus. We're adding on the opposite, so minus becomes a plus. Negative 3 plus 3 is 0. And so negative 4 plus 9 is 5. So that's the remainder. So the f of x into this form, there's your quotient, and it's 5 over your divisor. So that means that if you're looking at it, that means that y equals, x minus 3 is your oblique asymptote. So that's x, that's y. So and again, the slope here is 2. We could have a negative, but the slope here is 1. So the y-intercept is negative 3. Let's take it right there. And again, to make it easy, I just add the slope 1. Up 1, right 1, up 1, right 1, up 1, right 1. And again, in these examples, I had the oblique asymptote having a positive slope, just to keep it simple. So, again, to explain, as x goes to infinity, as x goes this way, this graph is going to taper towards this asymptote. And right here, as this graph goes, as x goes to negative infinity, this will taper towards this asymptote. And you'll see that in the next video when I do some more examples. So, we're having a quadratic dividing it by a linear, so we're going to get an oblique asymptote for this quadratic divided by linear. Again, quadratic polynomial divided by linear polynomial gives me an oblique asymptote. And that brings us to the end of this video. Again, if you like it, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of our YouTube channel called Math Fully Explained, which is just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.